Alrighty. Well, thanks for joining us, everybody. My name is Sam Myers, here with Eric Kaiser, and welcome to a Duct Up Situation. I sent Eric a handful of mildly inappropriate duct puns for titles, and that's the one we landed on. So hope you guys enjoy. I'm the building scientist, building science consultant at Retrotech. We manufacture blower doors, high-precision manometers, duct tester systems, airflow measurement tools. So thanks for joining us today.
Thanks, Sam. Appreciate it. I'm Eric Kaiser with TrueTech Tools, and my official title is Industry Engagement Manager, which basically means I get to come out here and talk to everybody and put on training and listen to you people and take the information back to our company to make sure that we're doing the right things for the industry and for all of you. Today we're going to talk about some duct work, a little bit of ductwork testing, talk about a couple things within ductwork and where to test, how to test, and how to really diagram it out to be able to find problems within ductwork systems. And then we've got some practical stuff up here, and you guys are going to get to crowd surf a flex duct. Anybody ever seen that before? First time for everything. Okay. So one of the first things we want to understand is static pressure, right? And what is static pressure? Static pressure is the pressure pushing out on that duct, and it's created when we push airflow into the duct, and it pushes a little pressure out. And we see that in there, and we test that, of course, with manometers, micromanometers, but it's an indication as to where restrictions are in a duct if we use it as a test method while the duct is operating. The blower creates that static pressure. We use the blower to push into the duct, and the size of the duct, the amount of the airflow going through, pushes back. That's that static pressure that we measure in there. And when things like this happen, it creates higher static pressure. Such beautimousness, right? Is that your house, Ed? Yours is worse? We should have a GoFundMe to fix Ed's duct system. That's what you get for sitting in the front row.
I'm pleased I found a seat.
Well, I'm pleased you came in. Ed Johnawalk, everybody. Angry Ed. So sometimes we have to go in and find problems in duct systems. And I've had a little bit of experience doing this, but one of the challenges is we go through, we start noting things down. And as technicians, sometimes we forget to take notes. Anybody ever forget to write things down and then go, oh, I took that measurement. What was that? Oh man, how am I going to show that? It was something really early I learned on when doing duct systems, because it can become very confusing very quickly if you don't take good notes and then try to remember later. So it's just a simple hand drawing. We can scratch that out on about any piece of paper, but I draw the duct system out and it helps me. Helps me to look, because then I might start taking readings and making notes. And I'm like, hey, okay, so return, here's my air moving device, whatever that might be. I'm looking on my return. You see equal pressure across there. That may be a sign if there's no duct size change, then I might not be pulling much air in from these two. I might just be pulling all my air straight through here. The static pressure tells a story when you start writing numbers down and looking at them all together. And if you follow the airstream through, you can tell different things about where there are restrictions. Finding those restrictions. Because when you have airflow problems, if you have complete system airflow problems versus airflow problems in one room, we need to separate those two out. Or maybe we have it in one or two spaces. So using a process like this then allows me to start visualizing this, seeing where those problems are at, and then pointing to them and saying, hey, if we look up here, right? I took a test, and this is my wonderful handwriting. So I'm sure all of you are perfect handwriting, and you can read all your tickets later and notes later on, 8 months down the road when the customer calls back, right? So a 0.14, but I went out farther in that duct, and it's a 0.03. You think that might be a problem room? Maybe. Or maybe there's a damper that's closed in there that was purposely limiting the airflow to that room. But if that room had a complaint on it that it wasn't staying comfortable all the time, I can then go down that duct, periodically taking pressure readings and figure out exactly where the problem is. Typically in a duct system, you want to see a nice, smooth decrease of static pressure all the way to the end. But if you get a sudden change, a massive change like that, that's a problem inside of the duct typically. Not going to go into super detailed things on full-on analysis here today, but a couple things I want to point out. When taking samples in ducts, we're taking a sample, say, with a static pressure probe, it is important to understand and be able to think about what the air is doing in the duct, especially when you are near corners. If the duct is long and straight, it's probably going to be pretty decent airflow in there. But if you're close to a corner, I like to think of these as streets with cars on them. If we have a nice long sweeping bend, that air moves really smooth around that. I think about a NASCAR track. How many sharp right angle corners do you have on a NASCAR track? None of them?
Yeah, they go left, don't they?
They only turn left. Okay. Well, okay, let's just say it maybe an F1 track then, because we can turn left and right there.
Oh, I thought you were being sarcastic. I was pretty impressed with that part.
No. I'm like that. You know, I think of these as cars going around a corner, right? So they're going left. They're going left in this case. You know, unless you turn it around and then they're going right. So if it's a sharp 90-degree corner, we have to slow down and then make the corner. But if we don't have really slow velocity in a lot of our ducts, do we? So if I take a measurement over here in this mess, what do you think is going to happen? Am I going to get an accurate reading? I'm going to get something. So here's my illustration of this. This is one I happened to find on a trouble job where I was looking for the reason that I had a lot of static pressure in a system. I had a lot of conditioning problems. I had multiple blower motor failures on it. And they finally asked me to say, why is this failing so often? Okay, let's do some deeper diagnostics. And to the right of this is a plenum coming off the top of a furnace. And this is some really nice, beautiful sheet metal here, isn't it? I mean, it looks good. So with one probe in the duct, you can see an empty hole up here. I got a 0.12 up in my duct static pressure. And I thought, well, that's not terrible. It's not great, but it's not terrible. And then I got to looking around, and I was like, wait a minute. So I put another hole down lower. Test port, thank you. I put another test port down lower, and I put a manometer, differential manometer, between those two ports, and I got a 0.08 differential between those two. Air doesn't like to make that turn. Those race cars don't go around those corners very well when the velocity's real high. But this was turbulence. Because that was trying to make that sharp turn one right after the other, there's a lot of turbulence in the lower half of that duct, and I couldn't get an accurate reading. This was my first hole that I put in here, and I actually drilled this one second up higher to be able to prove where the turbulence was happening in there and say, hey, this is a big problem, why we have airflow issues in the system.
One of the problems from what I see too is
Well, there's many problems with that. But yes, John's saying they lost their net free area on the turn. There's many problems with that duct fitting when you start looking at it. I mean, it looks pretty from an aesthetics point of view. And this is one of the things where unless you're testing, you're guessing, because a lot of people walked up to that and said, man, that's some really, really beautiful ductwork. It should work great. I've tested pretty duct systems that didn't work worth a darn, and I've tested some really ugly duct systems that actually performed well when you tested them and said, hey, the static pressure's low. I got airflow where I want it into my rooms. It works. Who cares what it looks like? We're not, in some cases, we're not going for the best looking duct system. Most times the customer's not going into their attic and saying, oh, this is beautiful. They bring all their friends and family every Christmas up into their attic and say, look at my pretty duct system.
But you said the key word there. You tested it compared to how it looks. And in this industry, it's 20 to 1. There's 20 more people saying. You want to say that again? Yeah, in this industry, it's 20 to 1. There's 20 people that are going to comment on a system on its appearance. And without being crude, I don't care about the appearance. I mean, I don't want my work to look like crap, but I'll take a measured performance diagnostic over what something looks like. But no matter how you slice it, the majority of our work gets judged by us as well as the general public on appearance. And that's less than ideal. How about that?
Thanks, Ed. I like that. And it does. And sometimes we want things to look good. If people are going to see it regularly, if it's exposed duct running across the inside of a restaurant or the inside of a house, maybe we do want it to look good. But if it's stuck up in an attic where everybody's going to go up there maybe to get their Christmas decorations once a year, as long as it's out of their way and they're not going to step on it, hey, if it looks a little bit ugly, fine. As long as it doesn't leak and it performs like you're supposed to and you test it out, who cares really what it looks like at that point? So, just some things to think about there. Now, that's enough of the slide deck, I think. We're going to switch over here. Sam's going to describe what we have, because what we've got here, well, I'll turn it over to Sam and let him talk about it a little bit. So, I think our flip over to the camera view. Look at that. Sam?
Cool. Thanks, Eric. So, Eric had this idea, for a presentation we could do. He's like, yeah, let's have a duct that goes out into the audience and let's just do stuff with it and see what happens, just to kind of show what happens in a poorly insulated duct system versus a good one. And so I took that and what I did was kind of mimicked a trunk line and a supply that would kind of behave similarly to what we would see in the field. But this fan that we're using, if you've never seen one before, this is a duct tester. We use this to measure leakage in ductwork. But here it's our air handler fan. So, and we created some different spots down the line here. We used plastic and PVC and Fernco couplings because this is going to be used a few times in different places. It ships well. It's not going to break and bend. So fingers crossed it'll last us the year. So this is just the first rough draft of this. But so we have a trunk line. And then we have a supply duct that we're going to be looking at. As you see, it's kind of weaving through the room here. And nothing too dramatic is happening. Nothing crazy, no crazy bends, no kinks or anything yet. But that'll change here in a little bit. And then we added a couple of other spots here where we can add some duct leakage to see what happens to our pressure there as we kind of change the duct leakage around in the system. You can see that they're labeled. This first gauge is reading our fan. So this is the total static pressure right here. So this gauge is reading leak number 1. Here is the supply duct, and then leak number 2 on the end. And the cool thing about this is these 2-channel manometers can read pressure and flow. So we can actually read the flow going through the supply duct. We can read the flow going through the leaks that we simulate. So as we change things around, we can see how it changes other things down the line as well too. Not just pressure, but with flow. So I guess one place that we can start here is if you're looking at these static pressures, again, this is the fan, and then this is down towards the end. Anybody notice anything interesting? Right. Yeah, so exactly, yeah, the one that we would think is smaller is bigger. You would think the higher pressure would be closer to the fan, right? Anybody want to take a stab at maybe what's going on there? Air's getting jammed at the end. Well, there's this phenomenon that happens sometimes called static regain. And we're pretty sure that's what's going on here. It happens a lot, especially when you go from a smaller duct to a larger one. And that is happening here. As this pipe fits over this fitting, it's going from a smaller to a larger. So sometimes that happens in the field. If you ever read that and measure that, that's likely what's going on. So we found that interesting as we first started to put this together. It was like, oh, that's not what I expected. But looking into it, it kind of makes sense. So one thing we can do now, we don't have, well, there's a little bit of leakage in it. This thing isn't perfectly tight. If you put your hand over this, you can feel a little bit of losses. But we'll add some in that we can measure. So here we're reading leakage on this first part. So we can add in a known hole opening. So we'll add a hole that's 11 millimeters across in diameter. Anybody notice anything that kind of happened to some of these numbers? They all changed. So duct leaks are a pressure relief. If you ever measure static pressure on a leaky duct system, and then you go in and do a good job air sealing that system, what's likely going to happen to your static pressure? It's going to go back up. So it's important to measure that again after you go and change the behavior of that duct system. Again, we're sealing up holes, so now that air is going to behave differently in there, and it's going to make that pressure go up. So I think that's one thing a lot of people don't think about. Sealing ducts is great, but it has an impact on other things. So we need to take our measurements again to see what else changed. So we'll leave that there. Obviously, if I make this a little more dramatic and put a larger hole downstream, let everything settle back out, then, yeah, there we go. Thanks, Eric. Then, yeah, it's just going to drop more. So as leakage increases, the static pressure goes down. So sometimes maybe low static pressure can be an indicator of a leaky system. It's not always maybe like a good thing, especially if we're going to go in and change it later and that static pressure comes back up. And in the middle here, we have a supply duct. I'm just going to cap this one back off to bring that static pressure back up. So we can see that the total flow right here on the fan is about 72 CFM that we're moving through. Let's see if I can get that glare off for you guys. There we go. And about 50 of that is coming through the supply duct. Static pressure is kind of remaining the same. It drops a little bit before, right when it gets here. But anybody want to make some changes to this thing? Let's add some crimps, or let's put some U-turns in it and see what happens. Before we make any changes, when we're looking at this duct, we're at 0.35 inches of water and about 51 CFM. Is this a unique problem you have in your house, Joe? Is this what you want to look at? So, Joe, you also just volunteered yourself to pack this back up into the box. So.
You just called it a box, right? So you're north. Shipping box. Yeah, down here it's bag. Oh, sorry. Tell what I did. It looks like this, okay? Normal install.
Anybody seen an attic like that before? So what happened here? We added a bunch of turns, a bunch of kinks. We completely lost our flow. We'd have to basically change and Well, if we reduced it, it would change it even more. But with that hole size that we had in here, we're not able to read flow anymore because the pressure dropped so much. Oh, into the ground, so it, yeah, jacked it up. There we go. Yeah, so it's kind of like having a piece of sheetrock over your supply boot and not cutting it out. We were at 50, so the starting 51 was at 51. Yeah, not a whole lot changed there. Exactly. So we're losing some flow there. Think about the worst. Think about the worst flex install you've ever seen, and try to recreate that. See what happens. So we're still hovering about where we were when we started. Somebody can be a scissor truss at the end and just wedge it in there at the end. Now things are happening. Yeah, we got a closed damper. There we go. Yeah, it really jumped back up there after you did that. So now we're kind of back to normal where we were a little bit. So we've got a few turns. We're still relatively straight, though. We've got a few turns, but nothing too dramatic yet, except for right there at the end. Yeah. Sure. Sure. This is just one duct. There would be a lot more. So, and usually installers are consistent. So if one's going to be bad, a lot of them are going to be bad. Yeah, we're getting more flow, and the pressure's dropping a little bit. Yeah. Yeah, so let's take note of where we are right quick. So we're at about 0.28 inches of water and about 55 CFM. So let's tighten it all the way up. We've got a little bit of leakage here before we get to it. We're going to see a big loss right quick when I change it. Hang on. So it came up a little bit. There wasn't a huge hole we sealed, but a little bit to kind of make it move some. But if we add a larger one downstream, so yeah, so it's going to relieve some of that pressure some, so it's going to drop. So this is about the best we can do here. So this is a pretty good, a good baseline of where we are. So, yeah, we do. So that's without the leakage. So now we're completely capped off. But if you've noticed too, as we've been making changes, it's been making changes to the total static and flow too. And like it was mentioned before, this is just one duct. So if we start to add, 12 of these, it's going to have a yeah, because there's only one. Right. Yeah. Yeah. Right. We would have to have more coming off and really make it move a lot more. Yeah, that's a great point. But yeah, maybe in revision 2 we can add a few more and see what goes there. Then we'd have to probably have a little bit more time than 50 minutes to go through that one by one. Yeah. Um, so just like a disconnected duct. Yeah. Yeah. And we see that sometimes. Yeah. I have a friend of mine that bought a house, and we did some performance testing on it, and we pressurized it with the blower door and noticed when we did some fog testing, it shot right down into the boot. There was a family of cats that got into the crawl space and was living there and really did some damage. It was completely disconnected. So sometimes we see that. So, yeah.
So in your simulation here, we've got a cap at the end, so our airflow is hitting that cap and it's backing up. So that would simulate like a closed damper, and it's backing up to your open duct,
Right.
which is our path of least resistance right now, and not allowing our pressure to back up enough to go into this duct.
Yeah, so it's all escaping before it gets there.
This is kind of a good representation too of when you're trying to balance the system and opening and closing dampers.
Right.
That you just can't go to a damper, close it, and call it a day because everything's affected.
It changes everything else. It can change the next bedroom over.
Yeah.
So it's good to go back and double check those things to see how it changed. So, yeah, if you make one change, it's, it just changes other things down the line. So.
Okay, could you elaborate on the fact that most people will not be putting this deep probe in their entire duct?
Yeah, so like Joe said, this is, we wouldn't go and measure a duct system like this in the field. I mean, this is just for us to take a deeper look into some things that would happen on this simulator. So most people aren't going to use a 2-channel manometer to do this too. They would use, a single-channel manometer like we have over here, just to measure the pressure really at the main point. But the purpose of this is just to kind of open your eyes to what can happen and what can change these numbers as you change things down the line, improve ductwork, improve leakage, make the right fittings and things like that. So yeah, usually most people are just going to read static pressure and then not measure really anything else down the line. There's this tool called a pressure pan. It's pretty much just a plastic box with weather stripping around so you can seal over either a supply or a return and read that with the high resolution manometer to get an idea of what the leakage is going to be with a blower door. And that can really tell you a lot about the performance of the system there without having to hook up a full duct tester and everything if you're going to do a blower door test anyway. So lots of diagnostics we could dive into on that, but fortunately we just don't have the time today to really do it, but we're happy to chat with you all about it later. But yeah, the point of this was just to show that it's all connected. You make one change, something else will happen down the line. So it's just good to kind of keep that in mind as you, whether if you're installing new ducts, repairing a duct, sealing ductwork, it's going to have an impact on the pressure and flows of other parts of the system. So.
Is there anything else they want to see?
Yeah, any other kind of demos that you want to see on this? Yeah, anything we can recreate while we have it set up. Okay. So you want to move 75 CFM through this? I mean, we can crank it up. Right.
What's the difference of 100 CFM going through a 6-inch duct or 100 CFM going through an 8-inch duct? But it's still 100 CFM. So you're missing the other parts of the equation.
Let's put
You're talking
Yeah.
let's block this off,
CFM, which
and I'll ramp this up
Okay.
just manually until we get to 100 CFM and we can see what
Um,
the static pressure is.
Yeah, yeah, it's been with the slider here.
Okay.
But maybe, can your fan ramp up to give us a little more?
Yeah.
I think that's reasonable.
Yeah.
Do we need to go with a bigger? We got a big enough port in there on the inlet side.
I think so. Yeah. So we're at 78 CFM going through here.
Okay.
Yeah. Is that where we wanted to go?
I was gonna try to get 100 CFM.
Oh, you want
going
to get
through
100?
this.
Okay.
Take your foot off it, John. Okay, so what Sam's doing is ramping the fan up to try to get 100 CFM going through this 6-inch flex duct, and we've got 50 foot of 6-inch flex that's mostly laid on the floor right now. We can get pretty close. And what are we at on static pressure in that duct now?
1.26.
Okay, so we've got 96 CFM going through 50 foot of 6-inch flex, and we're at like 1.15 inches of static pressure in that duct alone. Okay, so how good's that 6-inch flex working for 100 CFM? Maybe not so good. Yeah, now if we take that and straighten it out back in that, take that and walk it down that aisle and straighten that out back in the aisle. Or go out the door. Yeah, we were at like 97. Okay, so just by doing that, we've changed that from 97, we're up to 103 CFM, but we dropped our static pressure down to about 0.94. So we're better, still not great, but we're a lot better just by straightening that duct out. And if we pulled that duct really, really tight, if we, gave it a good stretch on that, I imagine we would improve by quite a bit. 50 feet is a lot to ask for 100 CFM. That's a long run for 100 CFM. Yes, the higher velocity, the higher the CFM. Yeah. Yeah, the higher the velocity, the more it's going to change, the bigger the changes are going to be. And there's a kink. There was a kink in the duct. That was that scissor truss where it got squeezed in, right? All right, turn it into a big piece of spaghetti. One big bowl of spaghetti duct coming up. How are we looking now? Now we're back under 100. We're up to that almost 1.2 inches of static by turning it into spaghetti. What's that? We could starve the intake of the fan a little bit. We could put a smaller range plug in there. That's 40. Let's see. We got a 74, so we're going to go to a 47. So we'll starve the intake of that fan. Did you change that? Yeah. Okay. So we reduced the fan airflow to 82, and going through the duct, we've got about 58 right now because we do still have some pretty significant leakage in this duct system in some strange spots due to the connections we're using. So by starving the inlet of that fan, was that what you wanted to see? Yeah, just by changing the range plug, because we've got it on it's not on a cruise, it's on a just set fan speed right now.
Yeah, the motor's still going the same speed that it was.
Yeah.
Yeah, great question.
Absolutely. What else?
Just so I'm clear, cruise, we're not trying to maintain a volume where, as we add restriction, we're dropping the flow.
Correct.
So it's simulating more along the lines of a
It
constant torque.
Yeah, it's simulating a constant torque or PSC. It's not a variable that's going to change with the static pressure. So if you're not familiar with what a manometer for a duct tester will do, they have what's called a cruise feature on there, where it will try to hold a constant CFM, and it will vary that fan up and down based on what that manometer sees as it's operating. Versus what we have it on now is just a static set fan speed. So when we put that new restriction in, what Sam did was change the orifice size inside the manometer so that it properly calculated the airflow. Thanks for that, Ed. Great question.
Yeah, so basically on these, you have the option to either set a pressure target or set a speed target. So if we set a pressure target, yeah, everything would change. That speed would change like crazy. But by just setting a speed target, it's just going to keep that motor running at the same speed no matter what we do, and then we can see those changes happen. So,
if you happen to have a duct tester in your company and you want to show installers, this is one way you can show installers what happens with flex duct when they coil it up like a big spaghetti bowl in the attic. And don't, yeah. Built a platform around the duct and squoze it down. Yeah. So just that one supply out of 8 really shot the whole static pressure up, so that to maybe a marginally sized duct system to start with, and then somebody kinked the one duct out of it and it changed the whole system, right? So that one. Yeah. Yeah, you've killed the airflow through that duct. So we're looking at, we got about 58 CFM right now and about 0.45 static. And then when you smash that duct with your knee, right? So that's full pressure with a knee on it. We just killed the static, and we dramatic increase in that static, and basically no airflow that we can measure through that duct anymore. So you're like the cable guy that crawls through the attic and kneels on all the duct. I mean, I got to admit, it is a great knee pad when I'm kneeling on, wood or trusses in a duct. That's a really soft place to put my knee. It feels good. Well, stick the manual under your knee instead of the duct. Okay, all right, I like that. Napping pillow? Oh, John, it sounds like. So you've heard? Okay. I've heard that it makes a really great napping pillow, but you got to take the outer liner off of it and lay on the fluffy pink stuff. That makes it even better. Yeah. It makes you walk around going like, what am I thinking?
If any of you ever wanted to do something like this, whether if it's at your shop or at a training center, I mean, this thing was pretty easy to build. 4-inch PVC. I mean, there was a couple of specialty parts that you could still just kind of make yourself. Like, for example, this bell housing that goes over. This is just an attachment for the duct tester for the European system that we have, because they have smaller ducts over there. But you could still make your own fitting, and then have your own, size trunk line that you would want to have. Add however many supplies you would want to add. So you can make your own little test ports to plug in and measure wherever you want. So it's inexpensive and pretty simple to put together if you just want to have a good classroom demo and have full control of the measurement and the flow and be able to see what's going on. So, yes. All right, so he's asking, we're measuring airflow here. Are we going to get the same flow down at the end? What do we think? Likely no. Yeah, especially if it's a really poor install. I mean, if there's a lot happening in between here and there, then we're not going to see the same that's going to be going on. Yeah. Right. Yes. Yeah. So there's one of these inside. So we have a known opening, and we're measuring both sides of it so we can. It's not a perfect measurement. I mean, it's not exactly like you would get off a duct tester, but it's close enough to prove the point of what we're doing today. Yeah. Any other questions or anything like that before we wrap up? The S turn. He was wondering, what would you do in place of that?
a solution. So the question was that double elbow that I showed earlier, what's the solution for that? The solution really, you can do a lot of different things. You want to have a smoother takeoff out of the plenum. That was a square takeoff. You want to have a throated takeoff, and you need to make that bigger, right? More free area to reduce the amount of static pressure in that. And I personally would have just taken it up as a nice slope and maybe a curve into my trunk line rather than trying to make a sharp S turn. The smoother you can make the turns, longer. You can have square turns in there, but you got to make the duct big around them.
Keep saying bigger.
Bigger.
You can't make a duct too big, and you got to have dampers. We can always force the air where it needs to go.
Okay, so Ed says,
The easier it's going to be to balance, but just big and dampers.
big and dampers. This is what Ed's saying.
It doesn't fit in a truck, right? Or too expensive.
How big is your truck, Ed?
I don't have a big one.
Okay.
Wait, did I say that out loud? I got a big one. You can't make a duct.
So you got a big truck, and you can't make a duct too big,
I use dampers.
and lots of dampers.
And if stuff starts to sweat, don't make it that big.
Okay, if it starts to sweat, don't make it that big.
But
All right.
you're not going to have velocity problems until you make a duct too small.
Yeah, velocity problems come from small ducts,
Matters, you gotta worry
not big.
for all intents and purposes. You won't make the free area.
Yeah,
I never said it that way, but that's a short way.
larger free area, because then we don't have the restrictions that create the high static pressure.
Say the same thing that I'm trying to say.
And my way of visualizing that is, especially in corners, more free area allows those race cars to go around the corner smoother, right? They have space to get around that corner. Whereas if you're trying to do a tight corner, if you're trying to take cars 3 wide and 4 wide on a racetrack and suddenly you're squeezing them into a really narrow corner, what happens? You get a lot of wrecks and spinouts over there, and it makes a big giant mess, which in that picture earlier, I kind of showed when you have that turn, we get spinouts and mess in the cars in the corner, and it's ugly, right? Whereas if we had made that bigger, so we lower the velocity going around that corner, and everybody gets to make the turn, and we don't have spinouts and wrecks and crashes on the sides. Did that answer the question? Okay, bigger ducts, more free area. Thank you. And if they sweat, make them smaller. All right, anything else? Well, we want to thank everybody for coming in and crowd surfing a duct.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.